So let's see how we moved from geocentrism to heliocentrism. We've already seen what we see. Let's recall what we have. We imagine the sky to be some kind of dome standing above the place we are in. And if we imagine that it's over encompassing things, so it's a sphere. Now, that sphere rotates, and we do see it at night with nice images like this around some kind of point. So if we combine that information, we see it as moving on a sphere. So it's a sphere that rotates once every day. But at the same time, we've seen that the planets and the sun actually move on another circle on that sphere. So it's as if the sphere rotates once a year, once a day, but then the sun actually moves on that sphere, like an ant crawling on the sphere. And it does one turn in 1 year. And the path it follows is that red line we call the ecliptic. Now, the question is, how do we explain all this? So is it the Earth that's rotating, or are the other things that are rotating? Obviously, we've got two options. One of them is the Earth is at the center, and everything else rotates around it. And that's basically what Claude Ptolemy ended up calculating as a complete model at the time in 150 AD back in Alexandria. Now, he was not the first to talk about geocentrism, so putting the Earth at the center. Now, obviously you might say, well, wait a minute, but there is a retrograde motion if the planets are moving around the sun, around the Earth, so how come we see them sometimes moving backwards? Well, I put the circle on the circle. Now, he invented epicycles. I mean, he was not the only one who invented epicycles. It was long before him. But his model was the most complex and the most complete, whatever complete means in that situation. So the Earth was not exactly at the center. The Earth was slightly away from the center, as you see in that diagram. And then there's another point called the equant point, which is basically the point from which you see the planet move, the center of the epicycle moving on that orbit that we call the deferent. So the equant is the point from which you see it moving at constant speed. And then you've got the epicycle, whose center moves on the deferent, and the planet moves on the epicycle. Now you can understand that the planet moves backwards, because in some places it's going to be moving backwards. And then you can explain retrograde motion. So you could do it. You're going to say it's too complex. Yeah, but you could do it. And the question is, if you could do it this way, and you've got another way to do it, how do you choose? Bottom line, in the absence of anything that says this one is definitely wrong, it cannot explain that fact, then you're not compelled to choose. And then you'll decide based on philosophical arguments, like I like to be at the center, like human beings are the most advanced type of life form. They are there to rule the Earth, and then they sit at the center. Now, obviously, the question is, what then brought heliocentrism? And we'll need then to look at how the ideas progressed. So one of the questions we might ask ourselves is, well, how did they know that the Earth was actually round, was a sphere? After all, when you live in a place, you just see it as plain flat. So how come we know that the Earth is round? What is the evidence? What cannot be explained except by a spherical Earth? Well, let's look first at the famous star trails. Now you see that the point is not actually right above your head. I mean, we've seen it on the star trail image, you could see it on the simulation, and you could do basically what I'm going to show you very briefly now on Stellarium, and it's going to show you exactly that same kind of effect. So we see the celestial sphere spinning. Let's not worry about who's rotating. Now let's assume that we move on the Earth between being at the pole or being on the equator. Well, suddenly the axis of rotation of the celestial sphere changes its position. And then when you're at the pole, the point is just above your head. When you're on the equator, the point is just on the horizon. So you see the stars going up and down, up and down, up and down, all of them. And when you're somewhere in between, like in Lebanon, well, you're going to see star trails. a point fixed and the number of stars that are going around in circles and others that rises. So that's an evidence for the spherical nature of the Earth. And the minute human beings started traveling and recording those kind of things, they immediately noticed that the only way to explain it is to have a sphere. Now try to explain that with a flat Earth. Come and tell me if you find an explanation. That could be a nice exercise, actually. The second one is eclipses. Now, during lunar eclipses, at some point people understood that it was the Earth that was hiding the sun from the moon. You'd see a curved shadow on the moon. Actually, today with photography, we see it very well. I mean, you do see that kind of disk, black disk that's coming from the Earth. You see it even better with that composite images. Now you're going to say, wait a minute, they didn't have photography, but they could see curved things. And Greeks were geometers. They knew geometry very well. So actually, just by looking at this, they could estimate, they could actually calculate even the radius of the Earth compared to the radius of the moon. So bottom line for now, they knew that the Earth was a sphere just by looking at many phenomena. We just seen two evidences of the round Earth. Now the question is, what can you build on that? Next video.